Okay, hello professor, this is Nathaniel Guzman. This is my presentation for the project. So the main intention was to use this as a receiver and emitter of the NFC cards or these tags right here. One second. Okay. Or these tags right here, which are used to open gates, passes, or payment, any type of those actions. And what I wanted to do was to store them and then be able to store them online in the cloud. So I was not using the Arduino Mega first. I was using the ESP8266, but I was having some issues with the low SAN connection, so I decided to go back to the Arduino Mega. So the circuit consists of the reader or emitter, which is the PN532. The reason why I decided to use this one and not the one that comes with the kit is because this one has SPI, UART, and I2C, so it gives you more communication capabilities. And so in this case, I'm using I2C, and this is configured using those two switches right there. In here, I have the LCD with the contrast adjustment. Here I have the Arduino that's connected to my computer. So let me go to explain the code. So what I was able to do is to use it as a reader and capture the UID and the length of the UID of the card. The UID is basically the message that's stored on the card. In this case, these two came with preloaded messages, so we were able to see it right here. This is the description of how I connected the display, basically using the LCD liquid crystal library of the Arduino. Another reason why I use that specific NFC module is because the libraries that it has are very easy to use. These are the libraries for that module specifically, these two. And this NFC adapter is a library that automatically takes charge of the I2C communication between the reader, the PN532, and the Arduino, so we don't have to deal with any of the bit shifting or register control involved in I2C. Okay, so this is our board setup. We configure the LCD and do a serial begin. The reason why we need serial is because I wanted to capture this data that we're getting from the cards into a text file, and I cannot do that with the Arduino. It's one of the limitations. I could do it if I had an SD card module and I could write it to the SD card, but in this case I will not do it offline the computer. So NFC.begin is part of the library. It will begin the NFC communication or the initialize the I2C communication with the PN532. This command right here, version data, that's equal to get firmware. This is just to get the firmware version of that chip. This is on the examples on the library, and this is used to see if we detect the chip or not. This was useful because this one, which is another one that I bought, I burned it and it was not communicating, and this was how I was able to figure out that it was actually burned. Okay, this sets how many attempts to read from the card, and this right here configures the board. Right here I'm just printing that I'm waiting for the card to be read at this moment, and then we go to the boil loop. So we need two variables. We need an array for the UID hexadecimal that we're reading, and we need also an integer for the length. Okay, this library can read passive NFC and active NFC. Active NFC is a card like this, but it has a battery and it's power. And this type of tags are actually powered by the core on the reader itself. So for this function, we're passing the type of card that we want to read and the device that we're using. It's a macro. We're passing the address of this array of the first element of the UID, passing the address of this variable too. Then if this is 1, if this is successful, it will return 1, and it will execute the if statement. I will first clear the LCD, and then we'll proceed to serial print the values that we're looking for. Again, we're using serial in here just because we want to capture this data in processing later. I will show that later. We'll see how the LCD printing the data into the LCD too. Right here, and we're putting this delay so we have some time to see it on the display. And right here, this is what we're showing when we have too much time waiting for the card. Right now I have it running, so you can see it's timed out. And you can see here on the serial monitor that it found the chip, but it hasn't found the card yet. So I'm gonna place one of them near. Oh, actually, I don't have the auto scroll. This is what's happening. Okay, now it's working. Right, so it's timed out again. I'm gonna place the card and it's showing the card. Now for the capturing of the values on the file, we're gonna use processing. This is the language that Arduino is based on. As you can see, it's very similar to Arduino. This is the language used for graphical user interface sketching. You can do a lot of interesting stuff with this language, games, and very interesting stuff with Arduino too. So in here, we see that the function calls and everything is like very similar. Void setup is still like the void setup in the Arduino. Void draw is or void loop in the processing. So here we're including all, we said import instead of include, all the processing serial libraries. We're creating a port object, a serial object named port, and we're creating a table. Processing can handle tables sort of like Excel on the programming level, and it's very useful to do this type of CSV/text files that we want to generate. On the void setup, where this size 500 by 500, this creates a window of 500 pixels by 500 pixels. It's going to be a black window that shows us that the program is running. Here, we're just saying that we're going to communicate, we're going to initiate a serial communication of this class on COM6 with this baud rate. We're creating a new table with this statement right here, and then we're adding the column data to the table. We can't see this right now, but we will see it on the CSV file. So here we have the void draw, background is set to black. So if we have bytes available to read on the serial buffer, it will go to this if and proceed to read the strings. And it will add a row for each value that it reads. And at the end, with this single statement, we save the table as a CSV. And this is all that you have to do on processing. I'm gonna show the folder right here. I'm gonna delete the previous CSV file and leave just the program. And for this to work, we need to shut the serial monitor out or close it, because we can have two programs using the serial port. So we're gonna close the Arduino, and we are here, and we're gonna initiate this program. It's gonna generate a black window, so I know it's recording right now. And I'm gonna see the display right here, and I'm gonna put a card on top of it. Okay, we found the card. I'm gonna put the other one, Okay, found the other one, and I'm gonna do the same one 2 times again. Okay, and I'm gonna do it again. Okay, so now that it did it a couple of times, I'm gonna stop the program here. I'm gonna stop it. I'm gonna go to my folder now, and we have the file. I'm gonna open the file with Notepad++, and ta-da, we have the output in a text file, which this is what main objective for the project. These characters are extra characters, but the rest of the information is very easy to get with if we clean the output a little bit. Well, Professor, this has been my project. Thank you so much and have a good day.